Good morning to everyone listening and welcome back for the 6th Annual Energy Storage Summit. So before we start with the first fireside chat and session of today, I'd just like to give a quick few housekeeping notes. So in terms of networking on the platform, we have a couple of networking sessions coming up throughout the next 2 days. So we have one at 2 o'clock today and one at 11:15 tomorrow. So you will be able to join some speed networking and you'll be able to discuss specific topics such as what we're about to discuss this morning, what policy drivers are needed to incentivize and accelerate long duration energy storage. And if you do have any problems with the platform accessing any sessions or asking any questions, then please do get in touch with live support. We'll be on hand all day to support you. All of the sessions which we have throughout the next 2 days, just like last week, will be recorded and available to access on demand. So please do get in touch and you'll be able to watch them as well. They're all available on the platform. So this morning, we've got, as I said, a fireside chat hosted by Andy Colthorpe, the editor of Energy Storage News. And we also have a couple of great panelists, including Javier Cavada from Highview Power, Anthony Price from Swanbarton, and Robert Hull from Riverswan Energy Advisory. And they'll be discussing, as I said, what the UK and also other economies and markets need to accelerate long duration energy storage. So just before we start, I'd like to say a huge thank you to everybody for participating last week, including the audience and all of your great questions. And I'd like to say a big thank you to our sponsors. So we have Trina Storage, our technology and industry diamond partner, our platinum sponsors, Wärtsilä and EDF, our gold sponsor, Huawei, silver sponsors, Arenco Group and Sungrow Power, our bronze sponsors, Chromalox, Centrica Business Solutions, Carbon Neutral Energy, Highview Power, Leclanché, Lion Tamer, Saft, Siemens Gamesa, White & Case LLP and Watlow, our supporting sponsor Honeywell, and our exhibitors InAccess and Ness. And of course, not forgetting our media partners who helped make the event a success. So now, without further ado, I'd like to get on to the crux of the session and introduce Andy Colthorpe, who will be leading the session. Hi, Andy.
Morning, Lucy.
Morning.
Hi, everybody, and thanks. Good morning. Thanks so much for joining us all. We're here to talk about long duration energy storage. We've seen, obviously, there's, it goes without saying that if you're watching this, you know there's been a momentous rise in energy storage globally over the last few years. Some people are always keen to point out to me that while the vast majority of that new advanced energy storage tends to be lithium-ion based, it's still got a long way to go to catch up with the legacy of installed pumped hydro plants. And really, when we look at lithium-ion battery storage, it tends to be the upper limit for that of duration tends to be 4 hours of storage, and of course discharge, which in some ways is as important, if not more so. The UK, according to our solar media market research team in-house, finds that there's over 1.2 gigawatts of operational battery storage, and very little of that actually is non-lithium ion at the moment. So what can we do as we look forward to a more renewable energy rich future, a more efficient energy system? We've seen events around the world where blackouts have been happening, and the causes of many of those are still very much up for debate, so perhaps we won't go in too much into say what happened in Texas, but certainly these things are bringing the idea of energy security and resiliency to front of mind for a lot of people, and so I'll basically limit my introduction to that. But I guess when we talk about long duration storage, so essentially, to my sort of journalistic layman's understanding, it's kind of anything beyond sort of the 4 hours that typically lithium ion can provide, that you can even get up to days and weeks of what would be called seasonal storage. And then you've also got a wide range of technology providers such as Javier company, Highview Power, that are going from anywhere from 8 to probably about 13 hours as kind of a sweet spot for the forthcoming opportunities. As I understand it, obviously, Javier, feel free to correct me as we go through this. So just briefly, our panelists, and as Lucy said, are very esteemed. Bob Hulls joining us is the founder of Riverswan Energy Advisory. He's been with energy storage and flexibility in that sector for the last 5 years, but certainly his experience includes throughout the energy system, particularly in the UK, is having served as a managing director quite chuffed to be introducing an OBE. That's not really happened to me much in this industry before. Anthony was in fact awarded the OBE fairly recently in the New Year's Honours list for services to the energy storage industry. And Anthony is with energy consultancy Swanbarton, which he founded in 2003.
We are having technical issues from Japan, it seems like.
The ESA. Can you hear me there, everyone?
Hi, yeah, Andy, you're cutting out a little bit.
Oh, okay.
But it seems
I'll
okay
try and
now.
persevere. Yeah?
Yeah.
Okay. Okay, well, apologies for that. So yeah, as I say, Anthony's with Swanbarton Energy Consultancy and founded the Electricity Storage Network. And last but certainly not least, Dr. Javier Cavada joins us also remotely from, well, we're all joining remotely, but Javier also joins internationally from his home in Spain. And he is the CEO of Highview Power, has been since September 2018. And Highview has developed and is commercializing a liquid air energy storage cryo battery, which I'm sure he can tell you more about, but it promises the opportunity to use, from what I understand it, processes from already proven industry technologies and recombine them into a means of storing energy. So to begin with, I'd like each of the panelists to give us a brief introduction. Tell us how you're defining long duration energy storage for the purposes of this discussion. And then very briefly, what applications long duration energy storage will need to provide and why aren't they currently supported today? So perhaps if we start in the order clockwise that I can see you. So Anthony, would you like to go first with that, please?
Okay, thank you very much, Andy, that's great. I've had an interest in energy storage for rather too many years, certainly back into the last century. And as you know, I run a small consultancy company, Swanbarton, but we also run the International Flow Battery Forum, and I've been interested in flow batteries for coming on for 30 years. Reason I got an interest in that is that we started looking at flow batteries because of the fundamental way that long duration storage could change the way that power markets operated. And back in 20, 30 years ago, renewables were a little bit of an outside activity. And we still were looking at conventional generation. Even with conventional generation, you still need storage and you still need lots of it in order to operate the system effectively, efficiently and economically. So in answer to your question about how would I define long duration energy storage, I would say that there's probably a good sweet spot at about the 8-hour point. That's when you really start changing from just only being able to use storage for small fluctuations and variations in the balancing the supply and demand to really making a significant shift in altering the generation profile and also altering the profile of your transmission and distribution systems so you can really economize on assets and use things most effectively and efficiently. So that's probably where the direction of travel that I would go in for this conversation. You know, what can we do at the 8-hour point? And the reason that we'd want to talk about this is that now that we've got more and more renewables coming on the system, and we've got a very, very increased let's call it a digital load, where people are switching in and out much more rapidly. We need to be able to balance, but we need to be able to balance over greater timeframes than previously thought possible. So we're talking about long cycle times for charges and discharges, and we're also talking about a lot of energy that we need to store. You know, we're not down in the megawatt hours; we're in the gigawatt and terawatt hours area. We've got to start being prepared to take energy from not just one time of day to another, but almost from one day to the next day, and occasionally over the week and so. So I hope that answers your point, and we can discuss some of those areas later on. Thank you, Andy.
Absolutely. Thanks, Anthony. So Bob, over to you. Your kind of definition, a working definition of long duration storage for today, and what sort of applications long duration storage will need to provide.
Sure. So I think what I would say is, rather than sort of repeating what Anthony said, I mean, more than sort of 6 hours is really how you define long duration storage. But I would, and probably less than 24, something like that. But the way I would define it is more in terms of the load profile that it's needed for. Because essentially during each daily load profile, you get the high peaks, and then you get the sort of shoulders of higher demand, you know, which may run for several hours. So in a similar way to the way in which combined cycle gas turbines would operate today, they would run for sort of several hours and then shut down when demand is low. Longer duration storage can run for those, should run for those longer periods, and then basically charge overnight. So that provides two services. One, demand turn up is becoming sort of more critical on power systems as you get generation that can't shut down or has to be paid to shut down. So having demand that can charge overnight, or generation that can, storage that can charge overnight and then run for longer periods during the day. But then you can also sort of see cycles over weekly periods where demand is always lower at the weekend. So having some storage that can operate for a number of sort of extended periods during the week, and then potentially have a longer charging period over the weekend, again, helps balance the power system over those periods of time. I think once you get, and over weekly periods, you probably go through cycles of whether renewables are available or not. So it allows you to sort of balance demand most efficiently over that type of period. I think once you get sort of longer than 20 hours or so, you then get into different types of storage technology like hydrogen and so on. So I think for the purpose of electricity markets, you know, probably looking at something like the sort of 6 to 24-hour period is probably the right sort of time frame, and is most useful as a resource to the power system. We're just talking about megawatts there. I mean, I'd like to sort of talk about the other services that storage can provide, ancillary services and so on. But I've probably had my spot, so I'll shut up now.
Okay, all right, thanks, Bob. Good opening gambit, anyway. And Javier, over to you. So the definition that you carry with you of long duration energy storage and the applications that it will need to provide.
Thank you, Andy, and it's great to be with Anthony and Bob in this panel because they completely filled up the definition of long duration storage. So they could not be in a bigger agreement with them. Definitively, when we come to the market, the conclusion we get what is long duration storage, just to paint it in another direction, is the amount of storage that enables you to run your grid stably with 100% clean tech, so clean energy, wind and solar. So 24/7 of renewable, which of course below 8 hours is pretty challenging. I mean, you can find application of 6 hours, 7 hours, but nothing less than that one. We have a project in the UK that we are in execution, supported by the UK government, by BASE, that is 5 hours, and the modularity of our technology is that we can move to 6 hours, and we can move to 8 hours, and we can move to 10 hours. That's pretty easily, just adding more tankage. And definitively that window of 8 to 12 hours is what we see mostly, and we see globally. I mean, we see in the States, we see in Europe, we see in Asia and Australia. When you have a pretty high integration of wind and solar or wind, normally less than 8 hours is you are already needing a backup of fossil fuel, which is definitely what we are going to be discussing today, how to avoid in that sense. So in terms of the second part of the question, Andy, on what kind of services, definitely we have two types of services as energy storage. We as Highview, we were born as a company in the early part of the century. I mean, and we were trying to piggyback on the hydropower or pump hydro civil engineering capabilities of the UK. That, I mean, as Anthony and Bob know better than I do, I mean, UK has been leading for quite long, and Highview was trying to develop a technology that was already well known and create a kind of pump hydro in a box, or pump hydro modular that you can deploy in the size, the scale, the duration that you need in every location, so locatable in a way. So to do that, you need storage capabilities, so shifting energy, obviously, and ancillary services. So all what pump hydro was already doing, like inertia, reactive power, big rotating masses, providing balancing services to the grid. So in a nutshell, doing all the job that thermal power has been doing so far.
Right, okay. Well, thanks very much. And so that's a great intro in, and yeah, I hope my internet connection will hold up. I believe it's been pretty good so far. We managed a whole year of virtual events last year. And so yeah, fingers crossed it holds out for the next half hour or so. So yeah, I mean, I guess the really big question is, and you know, again, perhaps this is one for coming from people that aren't as familiar with the sector as obviously you three are, but why aren't they currently being supported then, the deployment of long duration storage technologies? Now, obviously we've seen that from an innovation funding standpoint, I think some of them have been, but in a sort of systemic sense, what are the sort of policy drivers we need to support more long duration storage? And I mean, perhaps it's just a question that it is a fairly new thing for the, you know, for shares of renewable energy to be becoming so high that we do need more and more storage. Although, as Anthony says, that's always been kind of a pressing need in the background for the energy sector. So I don't know if we'll start maybe this one from you, Javier, in sort of reverse order. You know, perhaps as a technology provider, you feel that you are perfectly supported and everything's great. So, you know, again, correct me if I'm on the wrong tack here, but where do you sort of see that? And, you know, perhaps you can offer examples, not just from the UK, but elsewhere, I suppose.
Absolutely, Andy. Thank you. And your internet connection is going great now. Fantastic. So, but definitely the UK, I can say, is a good example. I mean, we at Highview, the last couple of years, we develop projects globally. I mean, we are very present in the States. We are very present in Latin American places like Chile and Peru. We're in Spain pretty present. Beyond during the lockdown, we are also business-wise present. Germany and Australia. I would highlight those markets as the ones who already have mechanisms that enable or will enable at short term. In short term, I mean in the coming 1 to 3 years, enough revenues to support financing and deployment of big projects. UK definitively has been launching end of 2019 the stability tender, the stability services pathfinder that is enabling technologies that don't produce active power, so produce reactive power. So in a way, is targeting storage technologies, is targeting long duration storage technology, such as Highview power technology, pump hydro, compressors, so mechanically driven thermal mechanical type of storage systems that you can get really revenues that can make these projects happen. So UK is also bringing the constraint management, so looking at the congestions that are happening in the country between where most of the renewable generation is happening, which is the northern part and Scotland in a nutshell, and the demand is coming to the south, to the border between Scotland and England, towards London, Manchester, etc. So there's an enormous congestion in those transmission lines, and in a way, when you are running gas-fired power plants or coal power plants, you are getting all those services as a default. I mean, you are getting big combustion machines, turbines, boilers that are providing connected with generators that are providing big masses of inertia, stability, constraint management. So you don't have that problem. But when you replace that with inverter-based technologies such as wind or solar or lithium-ion batteries, you are losing that balance in the grid. So you need those big masses. So UK, I can say that has done a big effort in the last 5 years. That is, you can see that is leading in deployment of lithium-ion and is now the last couple of years moving very actively. I mean, we could see the 10 points plan from the government in November, moving to reach those decarbonization targets pretty fast. So, but if we move to the West in the US, definitively there are places like California that not having these kind of mechanisms to provide you revenue, they already have capacity payments, they have capacity structures that give you a PPA, and you are acting like a generator. At the end, a storage asset like ours or a pump hydro is a consumer of electricity. You need to make sure that you consume electricity when the price is very low, or is even you are paid for filling up your storage, and you are a generator because you are generating back to the grid and getting this capacity payment. So in a way, mechanisms that enable storage to be the replacement of the gas peaking capacity and the open cycle gas turbine type of capacity. But you have all the spectrum of colors across the different countries I mentioned. So if we look at Spain and Germany, they are absolutely behind what's happening in the UK, and I'm sure that they are really learning and eagerly trying to implement a new scheme. Spain announced its storage strategy 2 weeks ago that is following very much the footsteps of the UK, knowing that Spain is going to be one of the biggest renewable hubs in Europe and globally. So that I think I consume my slot here from my colleagues.
Certainly. Thanks. And, I mean, I think California is an endlessly fascinating example for anyone that's, working in solar and latterly energy storage. It really kicked off the market through mandating that their utilities should procure a certain capacity. I think it's 1.35 gigawatts of energy storage about 5 years ago, and that was reached, ahead of time. And more recently, we've seen some of the system modeling efforts coming from places like the California Public Utilities Commission, where it's not a policy yet, but I believe that some of their staff recommendations have said that they should have at least 1 gigawatt of long duration energy storage on the California grid. And you've had some California energy suppliers called community choice aggregators that get to choose their energy mix. They get to use the infrastructure of the investor-owned utilities, but they get to choose the energy mix of generation. And I think a group of about 10 of those is currently running a request for proposals for long duration, 500 megawatts of long duration storage. And one interesting thing about that is that I've heard that there was more than 18 different technology providers and types actually applied into that. So I think on the technology, obviously we can get very sidetracked talking about technology, but we're doing a policy forum here, I guess. But it's really interesting to see those sort of, forward-thinking markets. And I think the UK has been commended many times from my conversations with international players for its forward thinking on lithium-ion energy storage and supporting that, certainly. So will be very interesting to see if we can see that going forwards for other types of long duration and energy storage going forward. So Bob, in your view, why aren't these long duration storage currently being supported, and what sort of policy drivers do we need? And perhaps, since you have the experience with Ofgem within, very deep within the UK energy sector, you could cite some sort of, your big picture view on where things kind of need to go, really, I guess.
So sure. So I perhaps wouldn't be quite as positive as Javier about the UK landscape at the moment. I think on the one hand, policy is very positive towards supporting long duration storage, and I don't think anybody could ask for much more on that. But I think the market mechanisms have significant problems in encouraging long duration storage. But this isn't a new problem. I mean, if you look at the 4 gigawatts of long duration storage that's currently installed in the UK, it was all built when the industry was privatised, and it was passed by Acts of Parliament because the same challenge existed then. How do you forecast a long duration, a long revenue stream for high capital cost assets? And quite frankly, without government support, those assets wouldn't have been built 30 years ago, all the pump storage plants and so on. We're now in a fully liberalised market and with all the market mechanisms. But what we've faced over recent years is lots of sort of very positive interventions through the electricity market reforms, which have seen huge growth in renewables. We've seen a capacity market come into place, and we've seen growth in balancing markets. But the challenge is that those interventions are designed to sort of work alongside a wholesale market. And they're just not giving long-term price signals to the services that are provided by long duration storage. So they're not giving long-term price signals for ancillary services. They're not giving the type of price signals that sit behind all the various revenue stack that a long duration storage asset might look at. Whereas things like batteries can look at some shorter timescales. If you're looking at long duration storage, you're probably looking at what the market mechanism is going to be 20 years out. And having some certainty about that is just not there at the moment. So I think the recognition is there. It is a difficult problem to solve, but the market mechanism on how that might be taken forward is not clear. And there's lots of different options. There's form of the capacity market to recognise ancillary services. There's use of a VAB model. There's similar models to the use of interconnectors, which were policy regime put in place. But this is certainly, I feel, a market that won't develop without a tweak to the current market mechanisms that will enable these long duration storage projects to go forward. And on an entirely, without giving them any favour, it's just recognising these are resources that are needed by the power system. And I think it's just a missing gap, if you like, that needs to be filled in the market mechanisms to give confidence for investors to go forward, which is not a subsidy, but is simply getting the market working in the way that it should.
Certainly. Okay. So Anthony, from your point of view, just to sort of avoid you having to double up on the same question again, sort of, do you see, what sort of ways can you envisage where policy can sort of help to fill those gaps that Bob identified? And perhaps do you have some suggestions in terms of the sort of policy drivers that we might need in terms of market mechanisms or otherwise?
To start off with, I think Bob's summary was brilliant in that saying, I'm going to put some extra words into his lips that he might not want to be associated with, but it's almost as if we had an electricity market and then we just kept tinkering with it to do various things. So we started off after privatisation with a market which we tinkered with to get renewables onto the system. There are a few, I don't think we struggled, we tinkered to get storage on per se, but we just actually luckily made storage easy to go on in the short duration mode because ancillary service prices were rising, the market for them was seen to be growing, and therefore if you could offer ancillary services with modern technology at lower cost than with conventional technology, you were onto a winner. And there was this sudden matching of increased certainty of ancillary services prices, which looked rewarding, with a dramatic drop in the cost of particularly lithium batteries, which made it worthwhile to put in a short duration battery. What we've not seen anywhere yet is the same argument that can apply to give project investors a sense that if they build a long duration project, they're going to get the same rates of return that they would if they built a short duration project. And therefore we come to say, well, what interventions would we want to make to the market to make that happen? Before the capacity market and the contracts for differences were brought into place, there were numerous consultations on how to proceed to meet the perceived gap in generation. And at those stages, it was felt typically that there was probably a 4-hour daily problem during winter, and how could we get over this? And the structure which came out was the capacity market. Has the capacity market worked? Well, it's worked in a little way. Is there something that we could do with the capacity market to make it more relevant to long duration storage? And if so, why should we do it? Well, we need to do it because actually we as both Javier and Robert have said, we need that long duration storage to operate the system more effectively as we get towards net zero. So we need to have more good storage on the system. That really means we've either got to modify something like the capacity market to make sure that it is specifically relevant for doing the jobs that we want storage to do, or we've got to put in a new market mechanism which offers that. The difficulty here is that the capacity market was designed as a generation fix, and storage is not just generation. Storage is the ability to give out electrons when electrons are needed on the system, but it's also the ability to absorb those electrons when actually absorbing electrons and getting them off the system is a good thing as well. And so you almost need a capacity market which works both ways. Can we have people who will be prepared during a storage event to take electrons for, say, between 4 hours and 8 hours, which would stabilise the system, in the same way that we would be prepared to reward them for giving electrons back into the system. So that's what we need. And there's various ideas come up, and I know that some folk have suggested that perhaps having a cap and floor mechanism in, which gives a modest certainty of reward for investors, would be useful. And that could be a way of stimulating the market. It could just be that we come out with a form of carbon pricing, which just makes it so attractive that by using storage, we're saving carbon elsewhere. That the carbon mechanism could be used as a driver to get storage on the system. If we come away from the UK and look at other countries, where are the best places for putting in storage? They happen to be in countries which have as close to a vertically integrated utility as you can get to. So we're in the middle of, if we want to have a really strong electricity market, then we look to have modifications to that market to make it work. If we just want to get towards a net zero solution, then perhaps having a totally different market structure might be a way of doing it. And that's a policy decision which I think is too big for this discussion now.
Right, of course. But hey, we're here to try and answer some of the big questions. So, I mean, I suppose that's the thing, isn't it? Like, if you then mandated, for example, the removal of fossil fuels, and I kind of keep going back to California because it seems at some point that was about 70% of what I covered energy storage news, even though it's a global site, just because it's where so much of this stuff is happening. But essentially, a kind of ban on new natural gas drives that need for storage, obviously, and you've seen that obviously the EU and carbon pricing is constantly, as you say, it's constantly been something that's come up. But I mean, do you think I guess one question we probably can answer today, perhaps, is that whether the benefits of long duration energy storage are being made clear enough so that policymakers, sit up and take notice. In terms of, the way I see it, there's kind of two broad, massive societal benefits that we could focus on here. One of them, as we mentioned, obviously, is decarbonisation. I think a growing one is air pollution reduction. Like something like 18 million people a year die from air pollution alone. And then on the other hand, obviously, I was about to say mid-pandemic. Let's hope we're towards the end of, 3/4 through pandemic, let's say, for argument's sake. In terms of economic stimulus and industrial competitiveness and really retooling the world for a post-fossil fuels future. Do you think the upsides of long duration storage are being made clear enough? And I think maybe we won't go to you first on this one, Javier, because obviously as a technology provider, you're going to, we'll start with you, Bob, and we'll go to Anthony and then Javier third this time around.
Thank you, Andy. And well, Anthony just mentioned in a very, very wise comment on where this long duration technology and also large scale storage is happening, where utilities are very vertically integrated, and is when the system is the user, is the consumer, is everything in that sense. And to your question, Andy, I believe that the policymakers know very well that this is all about the speed, ambition, risk, and it's quite complicated. When we talk about policy, risk, ambition, speed are quite at the other side of the line, or at least in the decision room. So definitively, the benefits that long duration storage is providing, I could start listing and make here a kind of commercial speech, etc. But this is more about what happens if we don't have it. So I mean, if we don't have it, all the targets we have for decarbonization, for moving to clean tech, for protecting our environment, for the climate targets. I mean, we discussed, Andy, you and me, that I'm a bit sick and tired about these commitments from certain countries. We're committed to this, committed to that for 2050. That's really irrelevant. I mean, so we're 2021, we're 8 years plus from 2030. So all the change has to happen in this decade. And the flow of wind, the flow of solar is happening, is demanding the flow of storage. And we need to put the base ground, we need to put the framework, we need to put the rules to enable urgently, emergently, larger scale long duration storage globally, everywhere. But definitively starting in those places where we need, as countries, as states, as grid operators, we need to mentally, vertically integrate ourselves and see how to run this system in an autonomous way without events like the one in Texas a few weeks ago, and being very greedy. So we really need 100% non-fossil fuel running grid. And to do that, I mean, it's not about 4 hours, 6 hours, 8 hours. It's about 24/7 wind and solar with larger scale storage. I don't believe there is one single person who doesn't know it. It's about how to inject that emergency or that urgency to make it work, instead of just scratching one project here, 2 projects there, and this should be a massive move.
Absolutely. And so from the other panelists, Bob, from your point of view, do you think the benefits of long duration storage are being made clear enough? And that can be either on the environmental perspective or from, the more wider economic perspective as well, I guess, and industrial competitiveness and what have you.
Well, I'd like to sort of say it's more critical from a point that you haven't got there. And Javier touched on this, and it's system security and stability. Electricity is absolutely critical to everyday life. I mean, as we can see from events in Texas and elsewhere, failures have very severe consequences, on human life and the way people live, and certainly power cuts, which we're fortunate to avoid in this country. If that started happening, it would really sort of undermine society in a devastating way. And the simple thing is that flexibility resources, the ancillary services on the power system are absolutely critical, as sort of demonstrated during the pandemic when we had sort of really low demands. Fossil fuel plants had to run to keep the system stable. And that's what's going to happen more and more in the future, is that those flexible type of resources providing inertia, voltage support and flexibility, simply being able to turn up or turn down generation sort of rapidly, is going to become even more critical. and there aren't clear price signals, long-term price signals for those resources, providing system security. And that's a real issue, I think, that, or a benefit that these type of resources can provide, which isn't valued at the moment. So I would actually put that above decarbonisation as being a key benefit, which needs to be recognised and valued in electricity markets in trying to ensure that these type of resources are available to fill that gap. And clearly, you know, that's not to sort of undermine economic stimulus, because that can sort of come with it as well. But I would personally put power system security at the top of the list.
Andy, can I just reinforce those points from Robert, because he's made a very strong point there. When we talk about applications of storage, we often go through ancillary services, bulk energy trading, and we talk about network reinforcement. But one of the things which I think trying to explain to an investor in storage is it's a bit like buying something that's a physical insurance policy. And we understand that when data centers buy an uninterruptible power supply, they're buying security. And if you were to look at the importance of electricity supply, and we've seen that, you know, we talked a lot about Texas, we've seen that in many places where there's a failure in the power supply, you just can't get enough storage. And you need big storage, both big in terms of megawatts and in terms of megawatt hours. And paying for insurance is the one thing that no one actually ever likes to pay for until the time that you really need it. And what we need to do as a matter of policy is find a way of rewarding that investment in one way or another. And it might be, for example, that there is a national storage bank, that we have some government-owned storage facilities, perhaps deep in the quarries at Corsham, which sit there most of the time doing nothing, but when we need it, we just turn them on, and that injects that supply of electrons or absorbs the electrons out of it. If we can find a way of monetizing that and creating some value, that will open up the market, help the manufacturers to get the costs of long duration storage down, which is one of the things that's inhibiting its growth, is that the early stage projects will always be a little bit more expensive than they might otherwise be. We can then make a real difference on this joint journey towards having sustainability and economy.
Absolutely. I mean, I guess in a way it's perhaps a little bit of an oversight of me to not include that as one of the core benefits that kind of asking you to comment on. But that said, it always seems like in terms of policy, resiliency seems to be quite a hard sell in the UK. Like, for example, how many floods do we need to have before we prepare adequately for them? So yeah. I suppose in a way it's not the kind of the fashionable headline benefit, but obviously I take your point, and obviously we've seen around the world that value of resiliency has really become a lot more important, but it's always very difficult to put a figure on it, I suppose. Would be another point there.
So what you could do, Andy, is to draw comparisons between California and Europe. In California, you got closer to an integrated system. Over here, the only mandated, the only instructed parts of the system are the DNOs, DSOs, and ESOs, which have oversight from Ofgem. Everything else is left to the market. And if you leave stuff to the market delivers what participants think they can get the best return from. So we need to find a way of cracking that nut.
Absolutely, and tough nut to crack, but obviously, I think that the technologies and the solutions are potentially there, and it's a way of figuring out how to implement that. With that, I think we're pretty much out of time. So thank you very much, everyone who watched. And obviously many thanks to our panelists for taking part. Hi there, Lucy.
Hi, I'm back. Thanks, Andy. And thank you, everybody, for the really interesting discussion and start to the day. What I've actually done, I know there's obviously lots more to discuss, and what I've actually done is suggested as part of the networking session later on today, we've turned into a breakout session, and one of the suggested topics for continuing the discussion is, the policy drivers needed for long duration. So I recommend everyone to, join that session. You'll be able to speak to people you've never spoken to before, and perhaps make some really good contacts and continue the discussion. So I'd just like to thank the panelists again and thank the audience for listening, and we will move on to the next session, which starts in just 15 minutes. And that is a presentation from Siemens Gamesa. So I hope you enjoyed, and thank you everybody for listening.
Thank you.
Thanks very much.
Thank you everybody. Bye.
Bye.
Bye-bye.